All right, so right here I'm getting about 1 inch 249.5, but again there is a little burr there, so I should deburr that. For time's sake here, I'm just going to go through and write down what I received there. So if I want to write, if it says 2x, it's good practice to actually go 1.247 and then go slash 1.249.5. So I write both those dimensions on there for the 2x. And they're both in spec, so I'm going to say yes. Then I'm going to measure the 1 inch 250B. That's on the opposing side, so that's over here. So same thing, go across to the mic, and I'm getting about 1 inch 244 right there. So 1.244, and yes, that's in spec. All right, let's see here. And again, you got a measurement of 1 inch 500 for the micrometer. I think you can figure that out in the diameter of this. Let's go show you the optical comparator quick. So the optical comparator, I'm gonna bring all this with me, is a tool that shadows light, and it'll give us a very accurate read on things, and it's very easy to use. So you walk up to the machine, what you need to do is make sure that this switch is on and just the profile illumination is on here. And with that, you should be able to measure your part. Now, you're gonna set your part in the stage and you're gonna put it between this light and then the lens right here. And you know, moving your focus in and out, we'll see, you can see my finger starts coming into focus. It's probably in focus the best, about right in there. And then I go out of focus here and then out of focus if I'm too close. So this stage moves back and forth where you set your part. So you can move this in and out, and that's basically your focus wheel right there, just to make it clear. To adjust the other axes here, you have your up and down here, which is on this machine considered your y-axis. So this will go up and down. And then you have your stage travel, which is your x-axis, and that moves back and forth with this. If you want to move a longer distance on the stage, you can actually turn this knob in, and if you close this all the way, it'll release it, and it will be able to slide back and forth quicker. And then you just loosen this up like a half a turn or so, and then it'll engage, and now it won't be able to move back and forth. So it's just a release on the lead screw for the machine. So what we want to do here, you could use this right here to support your part. I think I have focus issues when I use that for something like this. So I'm just going to do it old school, and how I usually would do it is just set a pin on the table and then take a V-block and set your V-block up against that pin, and it's going to square itself up. So this falls in the T-slot, and then this will square itself up against there, just so we're basically square against the table travel and kind of like indicating our part in on here. And then we're going to take our part and just set it on the V-block here. Now right now we can see that what we see there is out of focus. So the first thing I would do is go and focus this in just by moving my focus wheel down here and get it to look decent there. So you're never going to be able to focus all the way across the whole part. You'll be able to focus on the perimeter of it. So being the outside shapes is all you're going to see on here, and like the faces, like if we tried to go and focus in exactly on this face, you can see it's kind of blurry there, and that's going to happen no matter what. You're never going to be able to focus on that completely, because it's the trajectory of what it's doing is it's trying to focus on all of this flat, versus out here it's only focusing on the very center of it. But when you get to a surface like that, it's going to shadow across there a little bit, and the shadow won't affect you too much, as we'll see as we go through and measure this. So right now I have it focused in. Notice that the machine does have a DRO, so when you first turn it on, it just blanks out like this. At any point you can just hit any of these buttons, and it gives you an X, a Y, and a Q. So wherever you move the X-axis, you can see that it's holding the position. At any point you want to zero it, you just hit the button next to it, and that'll zero it out, and it'll start over again. Even if you were to go and loosen the table up there and give it the slide, it still recognizes where it's at. It has a scale on there, so it knows where it's at. So you can do it like that, and it's still just as accurate, and it'll be just fine. So it's not like you lose it when you loosen that table and move it quicker. Otherwise, yeah, should probably just kind of put this roughly in the center, so I have travel in both directions. I think you get about 8 or 9 inches on X, and on Y I think you get about 3 or 4 inches in height is the full travel of the machine. So right now I can see, you know, the perimeter of everything. What gets interesting is it's a little bit messes up with your head. Everything is upside down and backwards as it's displayed on here. So it takes the image, you can see my fingers on top, but on the screen, it's, you know, visually here, if I look, it's coming from the left side and it's on, you know, the top of the part. Up here, it's coming from the right side and it's on the bottom of the part. So everything is inverted and backwards, so it messes with your head a little bit, and that's just from the way it projects in here. It goes through this lens and goes through there, and inside the machine there's a bunch of mirrors that reflect and shadow everything and then send the image back, and that's what you're going to see here. So for right now, the first measurement we want to check on here is the 5/8 diameter. Now the 5/8 diameter is that diameter on the tip of the part where the intersection of that angle, that 45-degree angle, lines up with the face of the part. So this one here, we checked it out on the machine just with a caliper, but that's not very accurate. If we want to get truly accurate, we can measure it with the optical here. So what I'm going to do is go over to that angle, and I'm going to go down, and I'm going to find the intersection of where that angle meets the face. So I'm going to do this, and I'm going to kind of bring it right over to the face, and I usually check it right here. Even though the shadow's out a little bit, I don't count on that. I go right to this face right here, and then I'm going to bring it on the y-axis up until everything kind of lines up here. And right there, I'm just going to adjust that angle just a little bit so it's all lined up on that intersection point. From here, what I'm going to do is just go to the y-axis, and I'm going to zero it out, and I'm going to bring it up and check the opposing side of the part. So I just drag it up and over and look for the intersection on the opposing side. Same thing should happen. I'm up against that face right there. I'm gonna go up here, and it lines up good. 599 thousandths. So on my measurement of 5/8, I'm getting 599. Lost my pen. So back out here. So 599 thousandths is a little smaller than what we want it to be, but it's still in specification. We get 5/8, which is 625 thousandths, plus or minus 1/16. So I'm about 30 thousandths or 26 thousandths off a nominal, but I get plus or minus a 16th, which is 62 thousandths. So I'm still well inside the tolerance, but a little lower than I'd like to be. Am I good? Yes, I still am. While we're checking the 5/8 diameter there, there's also the 45-degree angle of how this face or that taper sits against the body of the part. So on that, I'm going to go, and I can do a few different things here. The best way to understand it is probably do something like this. I'm going to go over, and I'm going to spin this orientation on this dial on the overlay that we're looking at, and I'm going to make that line up exactly with our part. So I go right about there, and I'm just looking for it to all be in line, and I'm going to zero out this Q. This Q is our rotation. So now what I can do is move over, and I'm going to take this line, and I'm going to position it up against our angle that we just did. So I'm going to turn this up, and I'm looking at that line and how it compares to the machined part after we zeroed it. So I'm still off there. Make a little more adjustment, a little more. And again, you can see your tool feed lines and everything in here. Everything's going to come very prevalent because we're blowing it up 20 times larger than what it truly is. All right, so there I seem to be pretty lined up with that. I'm going to look up, and I'm at 44 degrees and 54 minutes. So what that means, and this gets a little confusing, that's not 44